Hello, this is our practice set for the lesson on more on functions. Please like and subscribe for more math help. Ask a question or leave a comment, and please check out the other videos we have on the channel. As always, pause this video to work these problems on your own, and then come back to check your work. Right, so for numbers 1 through 3, this is a vocabulary word literacy kind of skill. It might not seem important, but I have seen a lot of mistakes made by students in their heads saying the wrong thing in their heads to themselves. So this is an exercise in just writing how you would read the statement aloud. So now there's a little bit of flexibility here. And so I'll give you some alternatives for what you might have written down. This first one, what is important is that you are writing f of x, okay? That part is important. So f of x typically is how we would say the equal sign, but you could use the word equals. All right, that would be fine. And then like if we wanted to go all the way out, we would say -3 plus 8. Okay, that would be like the most you could possibly say. But here are a couple of alternatives. You could say f of x equals, and then you might do this part using 3x. Sorry, I forgot the x in there. Using the algebraic expression. Okay, so you might not write out the words -3 and 8. Okay, that would be fine. I would accept that. The important part of this, so if you're wondering, okay, well, what was the important part of that? It's that part right there. It's the f of x is or f of x equals, and then the rest of that typically is not too much of a problem. For the second one, the important part is f of 1 is 5. You could say f of 1 equals 5. You got a little bit of flexibility there. But again, the important thing is that function notation. It's important that you're not saying things like fx or f1 or f times 1. Okay, we want to make sure that we're not conceptualizing it that way. That tends to be the area that's problematic. And for this third one, we have a of r is pi r squared. Okay, that would be like the most we could say. We could say a of r equals, and then you might use the pi r squared. That way, I would be okay with that. Again, the important part not to miss is the a of r. Okay, and honestly, with this one, like I'm interested in that because I have seen a lot of students and heard a lot of students say like R2, which is not correct. So in your head, if you are saying R2, do try to stop that. It's not R2, that is R squared or R raised to the second power. Okay. All right, now this one is go to Desmos.com and graph that. Is it a function? So we have here the graph for that, and the answer is no, it is not a function. And what I did was I highlighted those 2 points. Okay, we've got the point 0, 4 and the point 0, -4, which as you can see are stacked on top of each other. And what they tell us is that the number 0 is mapping to more than one thing. Okay, that violates the definition of a function that each x maps to only one y. Now, there's actually an infinite number of points here that violate that. It's not just the 0, 4 and the 0, -4. Those are just the ones that I could click on, but there are an infinite number of points. So for instance, there's that point. And this point, okay, they are also stacked. I don't know what the coordinates are, but they're on top of each other there. We've got like this point and this point, and this point, and this point, okay? And even right in here, you're gonna have some that are really close together, and then obviously all the ones on this side that are stacked on top of each other. So, but the key there is no, not a function, because you're looking for like any kind of points that might be stacked on top of each other. And that, again, is to drive home the fact that y and f of x are not the same thing. Closely related? Yes, sure. Can f of x be, like, can you sub out a y for your f of x if you really don't like your f of x? Yes, you can do that, but that is not the same thing as every single y being synonymous with f of x. All right, these ones are practicing with that notation. So if f of x is equal to 4x, find f of -1 and f of 1. So we have here for number 5, f of x is equal to 4x. So f of -1. Now what that means is, okay, we've got -1, here are our x's, and then here's our y's, and the y's, like the pattern that we're using there, is 4x. So if I pull a -1 out of my domain, out of that first set, what will I be getting in that second set? Well, 4 times -1 is -4. Okay, so that will be the mapping. And then we're going to do the same with the 1. Now, the generic notation for that is simply f of 1. Okay, that would be true no matter what, like no matter what function we had. Okay, f of 1. And then you have to go and figure out, okay, well, what's the actual equation that we have there? So f of 1, if the equation is 4x, then it's 4 times 1, or 4. So in this specific case, f of 1 is equal to 4. Okay, looking at number 6, now we have a different function. And so I'm going to try to drive this point home a little bit more. Okay, so generically speaking, our y is an f of x. So generically speaking, that is always true, that if x is -1, then sorry, we got this. There we go. If x is -1, then the y value is f of -1. If x is 1, then the y value is f of 1. That's generic. Then what we do is we specify or sub in a specific function. So instead of this generic f of x, we are going to plug in a specific thing here, which is x squared. So we have f of x is equal to x squared. And so f of -1 is -1 squared. Now remember what that means. X squared is x times x. So what we want there is -1 times -1, which is +1. So f of -1 is +1, and so we could make it specific for this function. Okay, there we go. And then f of 1 is 1 squared. Well, that's just 1 times 1, which is 1. And then remember what we do here. We do not, like, we're not going to do this. Okay, I'll do it for a second. Okay, we don't list it more than once. Like either 1 is in that set or 1 is not in that set. So it turns out that this also maps to 1, and so it would look like that. And that is still a function. Remember, a function, each x maps to only one y. Okay, this is not a one-to-one function, meaning that like kind of oneness goes in both directions. But like the number 1 in my x's, that arrow only goes in one direction. It goes over here to the 1. Okay, so if I say, what does the 1 map to? Everybody's giving me the same answer. We don't have any contest there. All right, number 7 is graph that function by building a table of 3 inputs and outputs. So we would have a table, and you could list it with like your y, or in this case, we might, because of the notation that we're given, we might list it as f of x, okay? Or you could build a table that looked like this. Negative 2x plus 5. So you could put the actual formula there, all right? But either way, it's like our other set. And so you could have put anything in this table that you wanted. I'm going to go ahead and pick negative 1, 0, and 1. So f of negative 1 is negative 2 times negative 1 plus 5. Negative 2 times negative 1 is 2 plus 5. So f of negative 1 is 7. So when I plug in x is negative 1, I get out a positive 7. 0, oh, I love zeros. Okay, f of 0 is negative 2 times 0 plus 5. Negative 2 times 0 is 0, and 0 plus 5 is 5. So there we go. And f of 1, so negative 2 times 1 plus 5. Negative 2 times 1 is negative 2, and negative 2 plus 5 is 3. So we have 1 times 3, and then we could have picked any other numbers. So we're going to connect those to indicate that, yes, we could have picked more of the infinite number of numbers there. Now, everything that you have learned about lines does hold true. So you could graph this by using the y-intercept is 5, and then the slope is negative 2. So here's my y-intercept, and if you're going to use the slope is negative 2, remember that's negative 2 over 1, so that is your rise, that's your run, and so you would count down 2 and right 1, and that you could get it that way as well. So all the stuff you already learned about lines and how to graph them, still good, just practicing with this new notation and this new idea of like the mapping of the sets and the mapping taking a particular kind of pattern. Last three are just bringing it back into some applications. So you are saving money each month by placing $150 into a bank account. The total amount of money in your account is a function of time in months. So to interpret that, okay, we don't want to get too tied up in the language, is a function of time. All that means is it depends on time. Okay, so the total amount of money that you have in your account depends on how many months have gone by. That's what that verbiage means. That's what your notation is going to mean. It's indicating that dependence. So think about that. You're putting $150 in every month. So what that total balance is depends on time. Question 8 is asking you to write a function that models the amount of money in your account using A for the amount of money and T for time in months. And outside of like a lesson like this, you're generally free to pick your own variables in like letters or symbols, what as you want here. But I'm going to do this. A of T equals 150 times T. Now, take a look at what you did. If you just have like A equals 150 T, okay, that's not wrong. Okay, it's not incorrect. So if one of my students did that, I would not be taking off all the points. But they might get a little note back from me that says, write it as a function, since this is a lesson on functions. And so instead of just saying the amount of money in my bank account is equal to 150 times the number of months, I might want them to use this, which is the amount of money depends on the number of months. So the amount of money in my bank account depends on the number of months, and it is equal to 150 times the number of months. All right, 9 and 10 are asking you find A of 6. So to interpret that, that is the amount of money after 6 months. So if you've been saving $150 a month, how much do you have after 6 months. So that would be 150 times 6, which is like 3 times 2, and 300 times 3, 900. $900. Okay, so after 6 months, you have $900. Sound good? Not bad. And then after 10 months, so that's what that is asking for. It's asking for the amount of money in your bank account after 10 months. That's what that notation means. And that would be $1,500 that you've got in your bank account after 10 months of putting $150 in. One of the advantage of that function notation, because a big objection that I hear a lot is like, why do I need this? Like, why can't I just use the A and the T? I mean, you can, but here's what this tells me. If I saw this with no other information, I would still know that after 10 months, there were $1,500. Now, maybe there's like a totally different equation than this. Okay, there's a lot of different equations that could give us that particular number. But I know a little bit more. I know the time and I know the amount of money that goes with it. And so it is a little bit more informative than if you don't have that piece of information. You're just getting a little bit extra piece of information there. Okay, so that's that for the practice set. Please don't forget to like and subscribe if you found this video, this practice set helpful. Drop a comment or a question to engage and check out some of the other videos and playlists that are on the channel. And I hope to see you in a future video.